In this video, we're going to be looking at one of our first core practicals, and that is investigating the composition of inks. There's two parts to this core practical. One part is chromatography. We'll do that in a separate video. In this video, we're looking at simple distillation of inks, because what we're saying about ink is basically a mixture of, we think, water and some different coloured dyes. So with distillation here, we're going to see if it is we're going to see if the solvent is water, because we're going to try and separate the water from the ink. And we've got some sort of some basic simple distillation apparatus here. So just to label the apparatus up, we've got a thermometer, because when we heat the ink, so we're going to heat it down here with a Bunsen burner. We heat the ink, we're going to try and boil that water off the ink, leaving the dyes behind. Now, the thermometer will tell us what temperature the water is boiling at, or what temperature the liquid is boiling at, the solvent is boiling at. If it's 100 degrees, we know it's water. So we've got a delivery tube here, because those vapours are going to come out of that flask when we boil them, and we're going to try and cool them down over here. This is our cooling apparatus. We're going to have iced water surrounding that boiling tube, and that will hopefully cool the vapours, so they'll condense in here, and we're going to collect some water in there. So that's just a beaker, and we've got a tripod, and that's our ink solution there, and this is our sidearm beaker. Okay, question at the bottom. What is the temperature on the thermometer when the water is distilling off? Well, it should be about 100 degrees C. Now, the reality is we'll use an alcohol thermometer. This is an alcohol thermometer here, and it's got a nice red dye in the alcohol there. As the alcohol gets hotter, it expands and goes up the thermometer. Alcohol thermometers aren't actually that accurate, so it might read 102 or 98, but we'll see. It will be about 100. So the next question here, why does the collection tube need to be surrounded by crushed ice? Well, here's what I'm going to surround the collection tube by. I've got some iced water in that beaker there. And the reason the ice is there is because we need to cool the vapours so they will condense. And the ice just cools it down a bit better. So, next up, describe what you would see when the ink is heated. So to do that, let's do the experiment so you can see it happening. So I've got my apparatus here. Hopefully the phone will stay upright. I'll see how that goes. So first off, we're going to add some ink to this sidearm beaker. So we're going to put our ink in there. That's our mixture of dyes and the solvent, which we think is water. I've got my, we're going to collect our vapours, hopefully our solvent, our water, in that boiling tube there, which we're just going to keep cool in that iced water. We're going to put our thermometer in the top, so we can read the temperature. Let's try and turn that around so you see that from the front. And our Bunsen burner, which we shall put onto the intermediate flame there. Now, I'm going to heat this quite strongly just to start with, just to get that temperature up. Now, because this apparatus is a little bit basic, when it gets close to boiling, if we heat it too strongly, the vapours are not going to condense in that cold water bath, because it's not a very good condenser. So one of the things we're going to have to do is bring the heating down so it's very, very gentle. Now when students do this in class, most people heat it too strongly, and so the vapours, the steam can be seen appearing out of the top of the boiling tube, and that's one way we're going to have to try and improve the procedure if we want to make this experiment better. So we'll leave that heating for a bit and come back to it in a moment. Let's come back down to the questions. We've got next question here. Describe what you see when the ink's heated. Well, the ink will start to boil. the ink will start to boil. We will see liquid, clear liquid. We will see clear liquid condensing on the sides of the flask. And we'll hopefully have a look at that in a moment. What else will we see? We will see water starting to appear, starting to collect in the boiling tube. And we will see the thermometer will read 100 degrees. How can we improve the procedure? Well, we're going to need a better condenser, and you know, maybe I'll try and show you that in a moment. So what are the risks in the practical? The main risk is the flask might tip over. The flask might tip over. That could cause burns. So we want to protect against those risks of burns or scalds. That's the main risk. Okay, so how are we going to protect ourselves against that? First things we use Bunsen burner, we're using a naked flame, and this might tip over. I think we will use safety specs for this experiment. That's an acceptable way to manage the risk. To stop it tipping over, I'm going to put bullet points next to all these because I've only got a couple of lines here. To stop the flask tipping over, it's important we clamp the flask. Absolutely essential. Next, we're going to, if it does tip, we need to be able to move away so we don't get hot water on our lap. So we're going to stand up to do the practical. After the practical, when we're clearing up, the apparatus will be very hot, so we're going to leave the apparatus to cool down. That's vital. And the last one, when we take the heat away from the flask, the air in the flask will cool down. As the air cools down, it's going to suck air, or if indeed the delivery tube is in water, it will suck cold water back into the flask. So we're going to say, whilst cooling, remove the delivery tube from the cold water. So that water we've just distilled off. It's important we take the delivery tube out of that, because if we suck cold water back into a hot glass flask, it can cause the glass to crack. So there's how we're going to manage those risks. Right, so looking at this now, it's certainly warming up quite a bit. So I'm just going to take that Bunsen burner out. I'm going to turn that down, and you hear the roaring flame start to go. You can maybe just start to see some bubbles appearing on that in the flask as the ink starts to boil. I'm just going to turn this Bunsen burner down as well with the gas tap, so I've got a much smaller flame. So we can now see the ink bubbling fairly gently. It's got a very light flame underneath it. And most students will probably heat this too strongly, so it might even heat it so strongly that the ink bubbles right over to the side. I'm just going to take the Bunsen burner out because that's bubbling really quite strongly now. Okay, and I don't want to get any more heat in that, because we're trying to collect those vapours. We're not trying to boil it so vigorously that the ink goes over to the side. If you look closely as well, you might be able to see, let's put that in a little bit closer onto the, let's move that in a little bit closer now. You might be able to see a bit of condensation around the side arm flask. And if we come over to this side now, and you might be able to see some of those vapours, yes, just in there. We can see some of the vapours condensing in there. That's sucking up a little bit because I've taken the heat out. So let's put it back in. Let's put heat back under. So we start to move the vapours that way again. And we'll leave this going for a minute or two, and hopefully we might see that we've collected some water off this. Thermometer is currently reading 99 degrees, so as far as I'm concerned, that's 100, because the thermometers, these alcohol thermometers, aren't quite as accurate as mercury ones. So we've left this going a few minutes now, and I think it's about time we saw what we've collected. So I'm just going to take the tube out of the delivery tube, and what we can see here now hopefully is we've collected a decent amount of water by distilling it off that ink.